Here in Chapter 1, we are going to investigate the idea of functions and then limits, and that's where calculus starts. But first, we're going to concentrate on the idea of functions. We're going to talk about 4 ways that we can represent functions. Now, the key idea through all of this is the idea of dependence. So, for example, the area of a rectangle depends on length and width, and it's a specific kind of dependence too. For each length and width, there's only one area. You can't get 2 different areas from the same length and the same width. Now, you might have a different length and width that give the same area. That's okay, but you can't get 2 different areas. Can't get 2 different outputs. And in fact, that's the definition of a function. Function is a rule, which is usually given by an equation in our experience, that assigns each x in a set D, which is called the domain, to exactly one y value in the set E, which is called the range, and we'll write y equals f parentheses x. Remember, that means the value of the function f at x. It's sometimes helpful to think of the function f as a machine. So your x is your input, and then your function performs operations on your input and then spits out f of x, your output. So the set D is your domain, your set of inputs, and the set E is your range or your set of outputs. So remember that the graph of a function is the set of all ordered pairs x f of x, where x is in the domain of the function. So for example, in example 2 here, we've got a graph of y equal f of x. It's a piecewise function here. And notice that we've got some holes in the graph at several places here, and then we've got some jumps in the graph too. So first of all, we want to find the function value f at -1 and f at 6. So f at -1, our scale on x and y axis is both 1. We'll start at -1 on the x-axis, and we go up to the graph of the function and over, and here we're at height 3. So f of -1 is equal to 3. And then what do you think about f of 6? So f at 6 is right here. Okay, if you go up, there's an open circle. There's no dot. And if you stay on the x-axis, there's also no dot. So there's no value for f of 6. So f of 6 is actually undefined. And that happens. Your function is not always defined. Part B, we want to find the x value with f of x is equal to 6. So we're given the function value, the y value, and we want to find the x value that goes with it. So we will start from 6 on the y-axis. 1, 2, 3, 4, 5, 6 here. You go across, you hit the function, and you come down, and you're at x equal 1. So x is equal to 1. F of 1 is equal to 6. And it is possible to get more than one value. That's okay. Get more than one x value that gives the same function value. And then part C, they want us to find the domain and the range of f. So the domain is the set of all inputs for our function. And so we can start at -1, and we have function values, points on the graph, all the way up until +2, and then there's a hole here. So this would be -1 to +2, parentheses there. And then it picks up at 2, and we've got points on the graph between 2 and 3. So union 2 to 3. And then at 3, we've got a break in the graph, but oh, the function's defined at 3, and it continues to be defined all the way up to 6. So actually, we could do this. Union 3 to 6 is the next piece. But then these, you can combine these and just say, well, that's 2 to 6, open interval. And then union, this last piece where the function is defined is between 6 and 9, but not including 9. So this one, or substitute the open interval 2, 6 for these two. Those are equivalent domains. Range of f. So that's all of the y values that are covered when these x values are plugged into the function. So we can see that our highest y value up here is at 6, and we hit every y value down to 2, but not including 2. So we've got 2 to 6, close bracket at 6 because we're including 6. And then we also hit y values here between -2 and 0, because if you go across and over, you've got an x value that goes with it. So -2 to 0, don't include 0. And then we hit y equals 1 at all the values between 6 and 9. So we can add in one more point, y equal 1. So that's our range for that function. And again, visually, what I'm doing is I'm starting at the y-axis and I'm going across and I'm seeing if I can hit the function for any value of y. For example, in between 0 and 2, I can come across and I hit the function. But 0 and -2. Between 0 and 1 up here, though, I go across, I don't hit the function. And then also between 1 and 2, there's no part of the function that gets hit. So there's no y value in an ordered pair there. Or you can say that that y value has no x to go with it, so it's not a point in the range of the function.